Hello again. Time for another problem. In a certain manufacturing process, the mean diameter of holes drilled into a steel plate must follow a strict standard in order to maintain product quality. We take a random sample of size 45 and find a sample mean of 2.48 centimeters. The standard deviation is known to be 0.005 centimeter. A. Find a 95% confidence interval from U. So, you're given the three of the four values in the problem. That is, you're given the x bar, you're given the sigma, you're given the n, and you've got to find your z with subscript alpha over 2. So you're going to do that by taking 1 minus alpha is equal to 0.95, and 0.95 represents the 95%. It's just in decimal form. Then you're going to have 1 minus alpha over 2, and that's 0.95 over 2, or 0.4750. That's a probability, and the z that's attached to that is 1.96. So now you've got all the puzzle pieces for your formula. So you're going to have x bar of 2.48 plus or minus 1.96 times 0.005 over the square root of 45. And that's going to be 2.48 plus or minus 1.96 times 0.000745. And that'll be 2.48 plus or minus 0.00146. So when you do your subtraction, you end up with 2.47854 less than mu less than 2.48146. And if you notice, I put on there this problem sucks because it's too small. Well, let's look at another one. Still part of problem 2. This time you want a 92% confidence interval. So you're going to start out the same way with 1 minus alpha. Now it's going to be equal to 0.92, referring to the 92% confidence interval. And you're going to have 1 minus alpha over 2, which is 0.92 over 2, which is 0.4600. The z that's attached to that is 1.75. So you'll start putting things together again. You'll have 2.48 plus or minus the 1.75 times the 0.005 over square root of 45. Then you're going to have 2.48 plus or minus 0.000745. And that gives me 2.48 plus or minus 0.001303. And your final interval turns out to be 2.478697, less than mu, less than 2.481303. Now I'll try to stay away from ones like this on the test where the values are so close together.